Anyone who's used one of the modern digital oscilloscopes has experienced the phenomenon of a lightweight scope that looks big from the front but is really only a few inches deep and with very little weight to it, and yet you have buttons and knobs that get pushed and turned, and the tendency is for the scope to just keep sliding backwards as you're trying to operate its controls. And I'm sure various people have come to various accommodations with this. But in my case, I decided to make a bracket that would hold the scope in position. Sort of a cheap and dirty thing. I just went to the hardware store and bought a sheet of 25 gauge aluminum and used my bending brake and my sheet metal shears to form it into a simple Z bracket, which I then painted and utilized. So I'm just going to show the steps here for anybody who might want to do something similar. The gauge I used seemed like a good compromise between strength and not being too thick to cause a problem. The 0.025 inch thickness is also conveniently 25 gauge, at least when applied to aluminum sheet. Here's the entire sheet marked with the dimensions for my bracket, and I figured I was going to use my Bailey shear brake roller that is reviewed in another YouTube video of mine. It's supposed to be able to work on 12-inch wide material, but I found that it was just a hair too narrow on its frame to accommodate the 12-inch width. So I had to use my sheet metal snips, hand snips, to trim off just a little bit, kind of roughly, and then use the shears to do a width and then a length trimming job to the desired dimensions. Using my Bailey shear brake roller to bend the sheet metal wasn't probably the best idea, because with metal this thin, it's not really designed to bend it properly. And even though it gave a good initial bend, it did not result in a complete 90-degree bend. It just wasn't thick enough material for the design of the machine. Having encountered this problem before, I knew that with a good bend started, at least with the rear flange of the bracket, which has some decent surface area, all I had to do was set it against the table and push, and I could bend it a little further along the bend line. That wasn't possible with the much shallower bent section or flange at the front of the bracket. So for that I used my old, I think it was Harbor Freight bending brake that works better with the really thin metal, and was able to clean up the flange there. After a couple of coats of flat black enamel applied to the bracket, you can see here where it slips in nicely under the scope. Just lift the scope up with its handle and slip this over. This particular design wouldn't work too well if you're just setting the scope directly on a table, because there's nothing for the bracket to grab onto. But in my case, it was sitting on top of another piece of equipment which had a black bezel, and the front flange of my bracket kind of has the same color and vertical height as the edge of the bezel, so it just sort of hooks onto there and does not allow the scope to slide backwards. And here's a side view where you can see that the back feet of the scope bump up against the rear flange of my bracket. This bracket works really well in my case. The scope does not push backwards, it does not tip backwards. This was an inexpensive fix. A similar bracket could, of course, be made and perhaps anchored to the tabletop in some way. It could extend to the back of the tabletop with a flange that goes from the back of the tabletop to the rear of the scope instead of coming in from the front, and be perhaps C-clamped at the back of the table or something if you don't want to mar the table. And that would probably work just as well. So there's several different solutions to this, but this worked for me. I hope you found this interesting.